What we're working on today, as you can read up here in the beginning of the notes, is solving equations algebraically and graphically. We've done a lot with the algebraically. We've gone over solving quadratics, solving radicals. We've even done a little bit of our linear, you know, your x plus 3 equals 7 kind of stuff. So we're going to focus first on the graphing part. So to solve with your graphing calculator, what you want to do is you want to type the left side and the right side into your y equals. The left side would be your y1, the right side would become your y2. And then you want to look at your graph and make sure that the graphs and intersections are shown. If it's not, you want to use a button that we refer to as zoom fit, and I will show you that if we need to use it. And then we're going to hit calculate, which is second trace, and option 5, which is the intersection, and that's going to give us the point where it crosses. Another way you could do it is you could look at your table of values if the solutions are integer values. If they're not integer values, then you're not going to be able to look at your table for that. So let's take a look at our first example. They want us to solve to the nearest tenth. So I'm going to take this and I'm going to plug it into my y1. And what I want you guys to do is I want you to be doing the same thing. So if you need to pause the video, pause it so you can type it in. So in my calculator, I'm going to go to my y1. I'm going to clear out what I have in there. And I have second x squared to give me my radical. And it's x plus 4. 4 plus x. Leave my radical and I have another plus x. So then if I go back to my problem here, I'm going to type this into my y2. So go down to my y2, type in my 16, and let's take a look at our graph. So as you can see with our graph here, y2 didn't even show up. y2 should be a red line. It's not even there yet. So we're going to go to zoom, which is that third button up on the top. It's this red button here. You can see where I've pushed it. And then if you arrow up, you can see it right here. Zoom fit. It's option 0. So we're going to push a 0. And that's going to change our screen so that you can actually see things. But again, here's that one line. Here's my other line. I still can't see where they intersect. So my zoom fit actually didn't really help me too much. So if I look at my window here, my x's only go up to 10. So I'm going to go ahead and I'm going to change that and have my x's go up to 30. So then my x scale, what each little tick mark represents, I'm going to change that to a 5. So now let's take a look at our graph. Now we can see an intersection. My red and my blue lines are going to meet right up there. So what I'm going to do is I'm going to hit second and then the trace button, and I'm going to go to option 5, intersect. I want to know where my two lines intersect. So as you can see down here, it's asking you first curve, and my little blinky spider guy, as my teachers have always called it, is on the blue line, so I'm going to hit enter. And now it's asking me, is it on the second curve? So now the little blinky guy is on my red line, so yes. So I'm going to hit enter. And then it wants you to take a guess. You never really have to do that. Just hit enter. And it tells me my intersection is at where x equals 12 and y equals 16. So going back to my notes here, x equals 12 is going to be my final answer. Now we did that graphically. In order to check yourself, that's when we use the graphically. If we were to do this out the long way, which this would be great practice for your quiz on Friday, I would subtract my x, and then here we would take the square, we would square both sides. So I get 4 plus x equals 256 minus 32x plus x squared, which is just this written out twice and multiplied. I did it quickly there. So now I'm going to subtract my 4, subtract my x, So I get 252 minus 33x plus an x squared. So we're going to have to factor. We're going to have minus x, because this tells me my signs are the same. This tells me they're both negative. And so we got to figure out numbers that multiply to give us 252. Now, because I already did it in my calculator, I'm going to try 252 divided by 12. And I get a 21. 12 plus 21 would give me my 33. So I'm going to put 12 and 21 in there. So when I set them equal to 0, I get 21 and I get 12, which we know 12 is the answer. 21 gets rejected. That's one of our extraneous roots. So if you were to do your check and plug it back in, that wouldn't work. Let's take a look at the next one, number 2. Since this one is a multiple choice question, just use your graph for it. So you're going to type it in the calculator. I'm going to type this under my y1, and I'm going to type that one under my y2. So y1 is going to be x cubed plus 3x squared minus 3x minus 1. Clear that out. So we got x cubed plus 3x squared minus 3x. Oh, I didn't get my x cubed. I'm going to have to fix that. Minus 1. There we go. So x cubed plus 3x squared minus 3x minus 1, and then 3x plus 8 is my other one. So I'm going to clear that out. 3x plus 8. And then let's take a look at our graph. Which the graph there is a little bit funky because we were still set up from our last problem. So I'm going to go to zoom 6, which is our standard 10 by 10. So we got that it crosses here, and there's going to be another one somewhere up there. So let's look at our multiple choice. Which value to the nearest tenth is not a solution? So let's do our zoom trace on these. So I'm going to go second trace. I'm looking for the intersection. So now I'm going to move my squiggly guy. I'm going to arrow to the left. And I'm just going to move him a little closer to this intersection point, because that's the values I want to get. So if I have him nice and close there, I'll actually get that number, which is negative 1.1. So I can cross out that option. So now I'm going to do it again. I'm going to calculate the intersection. And again, I'm going to move my guy over to the left so that he's a little closer to the intersection over here. Oh, I went a little too far. Let's get him back. There he is. Okay, so I hit enter. He goes on the red line. Hit enter again. So negative 3.9, which is that one. So now we just have to find the other one. As I said, we know it's going to be up here somewhere. So I'm going to do my trace, choice 5. I'm just going to hit the right a lot so I can get over into the other side there. There we go. He's still moving. Keep moving him. Let's get him over that minimum there. Oh, he went a little too much. There we go. I know he's at approximately 2.4 based on that, so that works. Then he's on the red guy, and then the guess. So the intersection is 2.1. So the one that wouldn't work is that one. Alright, let's try our third one here. So we have f of x equals this. So that's going to be my y1. Then I've got g of x equals this. So that's going to be my y2. They want us to find the approximate solution. So when it wants the full solution, we're looking at one of these two. So Let's go type this in. Y equals, clear it out, clear it out. Oh, I'm sorry, he doesn't want one of these. So let's type this in. As I said, y1. So 3 absolute value of x minus 1. So 3 absolute value of x minus 1. And then we want 0.03x cubed, 0.03x cubed, get out of my exponent up there, minus x plus 1, minus plus 1. Let's take a look at our graph. There's our absolute value, and there's our other curve there. So we've got 2 intersection points here. So let's figure out what they are. So let's go to our zoom, trace, intersect. I'm going to move that guy a little bit more to the left. So we get negative, we'll round that to -1 and then 1.95. Let's see here, -0.99, yep. And let's see here, let's do the other one. Again, moving him over to the right so he's a little closer to the other intersection so we can actually get that one. So enter, enter, enter. So 0.5 and 0.5. So those were our 2 points. So if we take a look, these values over here, when they just write single values, that means those are your x values. So if you look at our 2 x values, none of them are that. So it's not those ones. So the only one that matches with that one, that's our approximate solution for that. Alright, take a look at number 4. So what is the solution to the system of equations here? Where y equals 3x minus 2, and then they graphed your other one for you. They graphed the g of x function. So what we have to do is we have to graph this one on here. So thinking all the way back, we've got a slope of 3 over 1. We have a y-intercept of -2. So I'm going to go to -2, put my dot, up 3, to the right 1, up 3, to the right 1, up 3, to the right 1, up 3, to the right 1. So let's see here. We know they cross here at 1, 1. So it's not that. It's not that. It's not that. Ends up being that one. 6, 16, yeah, that one's a little fishy. That's going to be up a little higher than that one. But 1, 1 is definitely there, so that has to be one of your solutions there. Alright, so here we're going to solve algebraically and check. So if you look at these 2 equations, thinking back to geometry last year, both of those are squared, so that means you have a circle. This one here is a line. So whenever it comes to these kinds of problems, you always want to plug the line into the circle's equation. So in order to do that, I got to get one of my letters on its own here. So I'm going to add my y, subtract my 3. So now I have y equals 2x minus 3. So I'm going to take this and I'm going to plug it in for the y up there. So that gives me x squared plus 3 times 2x minus 3 squared. The y was squared, so that's going to be squared. Equals 172. So now what happens is we have just the one variable. We have just the x. So I've got to take this and write it out and multiply. So that's going to give me 4x squared, -6, -12x, plus a 9, So then distributing my 3, I get 12x squared minus 36x plus 27 equals 172. Combining my like terms and bringing over my 172 gives us a negative 145 equals 0. So now we need to factor. So I set up my two sets of parentheses. 13 is a prime, so that means it's just going to be 13x and 1x. That gives us your 13x squared. There's really no other options for that. So then you should find your numbers that multiply to give you 145, which I already know would be 29 and 5. I'm going to make that one my negative, that one my positive. Again, when you're checking with your big smile, little smile, I would have a 29x here. This one, big smile, when I multiply, that would give me a negative 65x. Combine them, there's your negative 36x. So, continuing on, I would get x equals 5. Now I get 13x equals negative 29. So x would equal negative 29 over 13. Now that's only half of our answer though. We had y values all the way back at the beginning when we started this. So I'm going to use, let's see, I'm going to rewrite this. Negative 29 over 13. X equals 5. So I'm going to use my linear equation. I'm going to plug in what I got for my x. It's going to be a little easier over here on this side. That gives me 15 minus y equals 3. Negative y equals negative 12, so y equals positive 12. So one of our answers is 512. That one's the easier one. Over here, I would get negative 58 over 13. So I would add that over. Let's see here. 39. 97 over 13. So we would get negative 29 over 13, comma negative 97 over 13 is our other answer. And then you would check by plugging those both in, so make sure you do your check for that. And then our last one is very similar to the one that we just did. So again, I'm going to go ahead and solve to get y on its own. And then divide by 2. So y equals negative x plus 5. So now I'm going to take my negative x plus 5. And I'm going to plug it in for the y in that first equation up there, my circle equation. So I get x minus 3 times x minus 3, because it was x minus 3 squared, plus, if I plug in here a negative x plus 5, that would give me a negative x plus 7, because the 5 and the 2 make 7, times negative x plus 7 equals 16. So now we need to multiply this out, combine our like terms, so we get x squared minus 6x plus 9. When I do the same thing over here, I would get an x squared minus 14x plus 49. And that still equals our 16. So combining my like terms, I get 2x squared minus 20x plus 58 equals 16. So subtract the 16. 2x squared minus 20x plus 46 equals 0. Remember, we always want the 0 with our quadratic so we can try to factor, in which this has a GCF factor first of a 2. I made a little mistake here, guys. Right there. So that should be 42. So then this is a 21, which makes this now factorable. So this would be x minus 7 and x minus 3, because 7 and 3 gives you the 21 when you multiply, but when you add them it gives you 10. So we would get a 3 and a 7, and that ends up getting rejected, because if you set that equal to 0, 2 does not equal 0, which is a mistake some people have been making lately. So now we got to find our y values. So I'm going to plug my x in. So this gives me a 14 plus 2y equals 10. 2y equals negative 4, so y equals negative 2. So I got 7, negative 2 is one of my answers. So then over here I'm going to plug in my 3. So that gives me a 6. Subtract my 6. Divide by 2, and y equals a 2. So those are two answers, and again, you should be plugging them in and checking them and making sure they work.